Hello, so this is section 4.4 on trigonometric equations. So in our first example, it's actually something that's quite similar to what we looked at in the last section. And we're just going to be solving for cosecant of some angle equals to 2. And we're going to look for angles between 0 and 2 pi. So first, let's just change cosecant. Let's relate it just back to a primary trig ratio, which will be 1 over sine. And if we rewrite this, we know that sine, just find the reciprocal on, is 1 over 2. So when we kind of write this out, we can sketch this out first just to know where it looks like. Remember, it's all students take calculus, and since it's sine and a positive ratio, we know we're looking at A and S. So it's positive for sine in both of these quadrants, in quadrant 1 and in quadrant 2. So from here, we do know that we do have from 0 to 2 pi, so 0 we start from the initial arm, and 2 pi is when we just make it all the way back in the positive direction. We do know we have one option here. Actually, let's just write in a different color. So we do know we have one option here. And then we have a second option if we go around to the second terminal arm. So these are the two angles that will work for this. Okay, now to find that, we do need to look at our reference angles. So here in red, these two are basically our reference angles. So with our reference angles, we're just going to take our ratio here and leave it in the positive. So we know sine of our reference angle is 1 over 2. And if you recall from our table in section 4.3, you'll know that sine of pi over 6 is will give you the ratio of 1 over 2. Now that we know our reference angle, then we are able to figure out the angles that will work in this situation. So let me write in blue. So for angle number 1, the one leading into the first quadrant, it's simply just pi over 6. For quadrant 2, terminal arm, it's going to be pi minus pi over 6, which gives us 5 pi over 6, which means our final answers are, I'll just write it here, the angles that will work in this scenario include pi over 6 and 5 pi over 6. So these are the two possible angles. So this type of question is what we call a question that's looking for a particular solution. So you'll always be given kind of a restriction for angles to look in between, and your answer will be specific angles. Now we have a second scenario that's called general solution. So basically in this kind of case, you will be finding equations for all solutions. So you'll be writing out an equation that will find solutions, all possible ones, because we know when it comes to angles, we can just go around and around and around and find infinite number of coterminal arms. That word is from back in 4.1, if you forgot what coterminal angles are. So in the second one, solve this here. So this time we'll have to rearrange things around a little bit. So I'm just going to move, I want to isolate this trig section by itself. So we'll just need to shuffle things around. So we know root 3 cotangent angle equals to, we're going to move the 1 over first, 1. Going to divide both sides by √3, so isolate that angle by itself. So we know that cotangent equals to 1 over √3. We also know that cotangent equals to 1 over tan theta. So again, if we rewrite this as tan theta, we just need to find the reciprocal of this ratio equals to √3. So what does this look like? Well, oh, students, take calculus. So positive, so we're in quadrant 3 and in quadrant 1. So to figure out the general solution, we still need to find the standard position angles first. So from the initial arm, there is one angle here. Ooh, actually, I'm just going to write it a little further out. We do have one angle here. And we do have another one here. Now, in order to figure those two angles, we do need to find the reference angle. Probably recognizing a pattern for how to go at these things. We do need to find that reference angle. So for the reference angle, we do know it's related to our tan theta. So tan reference angle equals to √3. Again, you can refer to your table from 4.3, but we know the reference angle is pi over 3 or 60 degrees. In this particular case, because it didn't specify radian or degrees, I don't really care which one you decide to choose, okay? So now that we know our reference angle, let's just write down our two standard position angles so then we could figure out an equation to find all the other coterminal angles. So for the first one here, for the first angle, we do know that that is basically just going to be pi over 3. And as for my second angle, it's basically just, maybe I'll write it out here. As for the second angle, we do know that is going to be pi plus pi over 3. So this is pi plus pi over 3, which is basically 4 pi over 3. So we know the angle we're starting with is 4 pi over 3. Now, since we're trying to find the coterminal angles, when we're talking about radians, we're going to go all the way around, which is 2 pi. So this angle, first angle here, we'll have to add 2 pi n, or with 4 pi over 3, it's another 4 pi n. N is equivalent to all integers. Okay, so that is one way of writing out our general solutions. If you were planning to put this into degrees, then the equivalence would be 60 degrees plus 360 degrees n, or you're dealing with 240 degrees plus 360 degrees n. And again, n belongs to all integers, so this is another way of writing it. Okay, next question here. Determine the general solution of 3 secant x minus 6 equals to 0. So in this particular case, just be mindful that x really just means some angle, okay? It could mean the same thing. We're just using x to represent something that we don't know an exact number of, okay? So for this one, we're looking for a general solution. So again, we want to isolate that angle part by itself. So we're going to move things around. So let's just move the 6 over first, okay? That'll leave us with 3 secant x equals to 6. Let's divide both sides by 3. Boom, boom. We could simplify that down to 2. So we have secant x equals to 2. And we know secant equals to 1 over cosine. So that means if we have cosine, that equals to 1 over 2. Draw this again. Cosine is positive in quadrant 1 and 4. And when we look at the, well, we will need the reference angle. So when we have cosine, our reference angle, 1 over 2, our reference angle is pi over 3. So this is our reference angle. And here's the same angle. Okay. So we need to find our standard position angles, one of which is here. So for angle 1, that is just going to be the same as our reference angle, which is pi over 3. Then we have option number 2, which we can go all the way around this way, okay, which is going to be, angle 2. And that would just be 2 pi minus pi over 3, which will equal to 5 pi over 3. If you wanted to, you can also go from the initial arm this way. That is fine as well. You could, you could have also said that you wanted to go to the terminal arm in the negative direction, and that'll be negative pi over 3. That could also be the angle, and then you just find coterminal angles of that. It's up to you. So I'm going to stick with the options I wrote in blue. So that means I have an angle 1 equals to pi over 3, that's my standard position, plus 2 pi n. N belongs to all real integers. And 2 is 5 pi over 3 plus 2 pi n. And n also belong to all real integers. I'm just going to write in radians here. If you want to change that to degrees, in this particular case you can, but I'm not going to write that option down. You can just use your conversion and change it, okay? All right, example number 4. Ooh, this time is looking a little different, okay? But, and this time, since we do have kind of angles to look within, we are looking for a particular answer. So no general solutions for this one. So this equation is looking a little different, but if I kind of rewrite it a little bit, you might be able to see this. So this thing right here is actually equivalent to cosine x and cosine x. Okay, that's what it is equivalent to. So when you think about it, if you think of cosine x, we could kind of treat cosine x as, say, a. And if we replace a into this equation, then we basically have a squared minus 3a plus 2 equals to 0. Now, this is just a quadratic that we're all so familiar with. And how can we solve it? Well, we can factor, right? So that just breaks it up to a minus 1, a minus 2. Now we're just going to replace cosine back in. So we have cosine x minus 1, cosine x minus 2. So now we will have to solve each of these separately. So we do know we're going to make this equal to 0, and we're going to make this second one equal to 0. So let's look at both of them separately. So the first one here, if we have cosine x minus 1 equals to 0. Get that angle by itself, so we have cosine x equals to 1. What will that be? So it might help to draw something out here. So if we think about our unit circle, now remember, cosine of some angle, so x in this case just represents some angle. On a unit circle, it'll give you the x value. So on a unit circle, at what point is the x value equal to 1? So since the radius is 1, this is the only point on the circle where you have an x of 1. And what angle is that? Well, it's 0. So in this particular case, x equals to 0. Okay. Now let's look at our second bracket here. We have cosine x minus 2 equals to 0. So we have cosine x equals to 2. Now this time I want you to think about, well, when you have cosine of some angle, the ratio is always adjacent over hypotenuse. And as you may, and in this particular case, since it's 2, it means we have probably 2 over 1. Now, you probably remember with a triangle, hypotenuse is always the longest length. So if you have a side of a triangle, especially a right triangle, that is apparently longer than the hypotenuse, that is not possible. So in this particular case, x actually has no solution. So whenever you have a ratio, you should never have anything bigger than 1. Okay? If it's bigger than 1, you have no solution. So that means we're only looking at the terminal arm at 0 degrees or 0 radians. Okay, that is what we got from this answer here. And if we're looking in between negative pi and pi, the only angle that is at the same terminal arm as 0 degrees is in fact just 0. So x equals to 0 degrees, or 0 radians. 0 radians. So just x equals to 0. Boom. All right, last example here. So we have cosecant squared minus 1 equals to 0. So this time we're just going to, let's just go with the same tactic we did before. So we're just going to say cosecant theta equals to a. That means a squared minus 1. Difference of squares. A plus 1, a minus 1. So if we put back the cosecant, we have cosecant theta plus 1, cosecant theta minus 1 equals to 0. So we could just break out these two again. So here we have, here we have cosecant theta equals to minus 1. And remember, cosecant is 1 over sine theta. So that means we have sine theta equals to negative 1, because when you flip 1 upside down, it doesn't make a difference. And that would actually be, so if we think about sine this time, similar to, if you kind of go with a similar thought process as the last one, we know sine of some angle on a unit circle is also equivalent to the y. Now, at what point is y at negative 1? Well, that's just this one right here. This is when y is at negative 1, right? So that means the angle we're looking at here is theta equals to 3 pi over 2. Now, for this other one, we have cosecant theta equals to 1. And this again equals to 1 over sine theta. So sine theta equals also to 1 because reciprocal of 1 is still 1. And when is y value equal to 1? Well, that's up here. That'll be this arm, which means we're looking at pi over 2. Or some of you are thinking in degrees, 90 degrees. Okay. So now that we have these two angles, again, let's see. We are looking between 0 and 2 pi. So starting from the initial arm, we're just going once around. And what are the arms? What are the terminal arms that we hit? So we do hit. So in this case, our angles include, we do hit this first arm. Okay, so that means we do have pi over 2. That's within what we're looking at. And as we go around, we also hit 3 pi over 2. And those are the solutions. And that is it for this section.